welcome to True Projects. In this video, we are going to explain about joint network selection and service placement based on particle swarm optimization for multi-axis edge computing. Introduction. The project proposes edge computing to improve mobile device service quality, battery life and response delay by offloading tasks to cloud servers. This approach optimizes battery life and reduces processing time for computationally heavy tasks. However, it also introduces task overloading on specific edge servers when multiple mobile devices send requests simultaneously. To address this issue, the project introduces network selection service placement based on PSO and HHO algorithms. The PSO algorithm evaluates each resource to find optimal solution considering factors like physical distance and available load on each edge server. They choose an edge server within the least distance and the load is chosen as the optimal network and the service is placed on that chosen edge server. Objective. The objective of the project is to enhance mobile service quality, improved battery life and reduced response delay. It proposes task offloading to cloud or edge servers for heavy computations. The PSO and also Horst-Hertz optimization, which is HHO algorithm, is introduced for optimal edge server selection considering distance and server load. This aims to dynamically manage resources and avoid overloading and deliver efficient services to mobile users. By offloading tasks to nearby sources and intelligently distributing the workload, the project seeks to provide faster responses and better overall user experience on mobile devices. These are the requirements for implementing the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDE of 3.7 version is required. Methodology. These are the design modules for execution. First one is queue worker. This module is responsible for queuing all incoming requests evenly and sending them to edge cloud for processing. It simulates the task offloading process where requests are offloaded from mobile devices to the cloud server for computation. Second one is Edge Cloud. This module represents the Edge Cloud server which receives requests from the queue worker. The requests are sent unevenly every second to selected edge servers for processing. This module is designed to simulate real-world scenarios where the workload on edge server varies. Next one is Local Run Task. This module allows the simulation of local task execution on the mobile device itself. It uploads an image, runs a face detection task locally and then calculates computation time or cost required for processing the task. Fourth one is Offload Evenly Task. This module simulates offloading of tasks to the selected edge server using proposed technique particle swarm optimization, which is PSO. It is used for network selection and service placement in multi-axis edge computing. The PSO algorithm dynamically evaluates edge servers based on physical distance and server load to find the optimal server for task offloading, reducing response times and efficiently distributing tasks. Fifth one is Horst-Hertz optimization algorithm. As an extension, the HHO algorithm introduced for edge server selection inspired by Horst behavior in Hertz. It evaluates all edge servers in the terms of distance and load to choose the most suitable server for task offloading. Further, optimizing network selection and improving performance, it uploads an image, offloads the task to edge cloud for face detection and computes the total time for task offloading. Fifth one is Unevenly Task Computation Cost Graph. This module is responsible for plotting a graph that represents the computation cost for executing tasks unevenly. It compares the computation cost of locally executed tasks and unevenly offloaded tasks. Sixth one is Evenly Task Computation Cost Graph. This module plots a graph that compares computation cost of locally executed tasks with tasks evenly offloaded to the edge cloud. It demonstrates the potential benefits of using the proposed PSO-based technique for optimal network selection. For execution of the project, first open the code folder. This is the code folder of the project and this is the dataset file which is named as images, and these images will be used for applying the algorithms. And these two are the main code files And these three are the run.bat files. Instead of executing the project in command line interface, we have created Windows batch file for execution. So, to run the project, first double click on run worker.bat file. Queue worker is started, and now double click on run edge cloud.bat file. Here, multi-edge thread-based edge cloud started, which will process requests unevenly from any mobile at any time. Now double-click on run.bat file to start mobile application simulation screen. This is the graphical user interface of the project. With this, we can interact with the program. So, now click on the button Generate Mobile Devices. Here, on the screen, all blue color circles are mobile devices and green color nodes are edge servers, and every second mobile devices will change their location and then select near edge server. Now click on Local Run Task button for performing tasks locally and get computation time. Select an image, click on Open. Here, I selected the image and uploaded it. So here it performs face detection task. Close this image. Here, it is computing the time, and then same task will be offloaded to edge and then compute computation time and compare with the local time. So now click on the button Offload Evenly Task. Select the image, click on Open. Here also image is detected and it has calculated the computation time and cost. Now click on the button HHO Optimize Offloaded Evenly Task. Here also image is detected and it has predicted the computation cost and computation time. Now click on the button Unevenly Task Computation Cost Graph. Here in the graph, x-axis represents the name and y-axis represents time, and here algorithm names are represented. HHO algorithm time is 2 less and so not plotting in graph, and now click on the button Evenly Task Computation Cost Graph. Here also HHO took less computation time. Now click on Latency Graph button. Here also HHO algorithm has took less time. Now click on the button Throughput Graph. Here on the x-axis it represents the algorithm names, and on y-axis latency time. In both algorithms HHO took less latency, and in throughput graph HHO took long time. So close this graph. Close this UI. Conclusion: finally, by implementing job offloading to cloud edge servers, the project successfully addressed the challenges of improving mobile service quality, lowering response latency, and increasing battery life. Particle swarm optimization for network selection and the Hertz optimization algorithm extension for edge server selection provide efficient, dependable solutions. The project proves the success of the proposed methodologies through simulation and analysis, demonstrating that PSO and HHO optimization strategies result in lower computing time, latency, and higher throughput, thereby improving the user experience on mobile devices.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.